Good afternoon, everyone. After lunch, somebody said this will be one of the toughest sessions, but I tried to make it as entertaining as possible. And I'd first like to thank Polyconnect team for giving us this opportunity, and I hope I today add some value to your time. You had given your time today, so you had an option to be anywhere else, but you chose to be here, and I congratulate all of you for doing that. So starting with my presentation, the topic I selected was understanding weathering. I'm a commerce graduate, so I used to learn technical terms from Prashantji, who is one of my gurus, and the industry has supported me a lot in developing my business. So just a brief about my company. I started this in 2012. I'm a part of a family-owned business group. We are Omia group of companies. We also do blown film extrusion. We do injection molding. We do EPS packaging. We do PET stretch blow molding. So actually I started in 2012. If people remember, it was a subprime crisis time when I graduated, completed my MBA, and I started with 100% compostable polymers. So we used to buy our PBAT from BASF, and we used to import PLA from USA, and then we used to use those raw materials in our current processes, injection molding, PET stage blow molding, and that's why we are named Green Age. And but because of the India being a price sensitive market, 2012 we were not able to push those products, unfortunately then, but fortunately this year we have again started compostable processing. And so in 2013 we introduced rotational molding compounds, and I'm fortunate to have a friend of mine who was the first customer of ours, that was Kaka PVC, who had told us to enter into this business. They are the reason why we are into rotational molding compounds. And so then gradually, after guidance from different bodies, we try to develop a market for compounds which are not available in India. So we started importing metallocene, we started importing hexene based compounds, octene based raw materials, and started developing compounds out of that. So we currently have representatives in 3 continents. We have a stock and sell in Africa, in UAE, and in Belgium. We are a 9001 2015 TUV suit certified, and also a StAR export house. And I would like to credit the information whatever are here are because of these 3 companies. One is QLab, and second one is Atlas. They both are into manufacturing of weathering equipment. And then I would like to thank Paritoshji for helping us in doing all our testings on their QLab machines in CPET. So we have done like 12,000 hours of UV weathering tests on all of our grades that we give. So the basic question everybody asks is, how long will your product last outdoor? Somebody said that there was a tank which lasted for 2 years and one which lasted for 25 years. And so our question mark is, what should be the ideal life of a product? So as rotomolding, all of our products are for outdoor exposures. So all outdoor exposed products are exposed to weathering. So just taking an example, road barrier would last for like 3 to 7 years, and then it would look something like this. Water storage tank, this unfortunately or fortunately 12 years back, this is from our material. The tank turned out like this. Fortunately on the lid, there was a lid on the top, that's why the color of the rim is not gone, but the tank color is gone. And so this taught us what should we look in the pigments that we use, or the master batch we use. So average life I would say would be around 5 to 20 years. Then you can see this building, it's 4,500 years old, and still it has, you can see some weathering effect on the same. So first let us the textbook definition of weathering is the material properties are exposed to sunlight, heat and water. and water predominantly in humid, dew and rain, and because of this there is changes in the material properties. That's what we call weathering. So basically these are the three main enemies of the weathering: sunlight, heat and water. So since all of our products are outdoor, if you consider automotive parts, you will have parts which are inside the cabin, you will have fuel tanks which are installed outside the equipments. So every part is exposed to sunlight either directly or in indirect way. So all of our rotomolding products are majorly of the outdoor exposures. So testing your product on UV is almost very important. So now to define sunlight. So there's all the lights in the world that exist is defined in an electromagnetic spectrum. So this is how it looks. The first time I saw it, I was completely confused. What does it mean to say? So to explain it easily, just imagine a piano. So piano will have different keys. All the keys are different types of lights. So now all the light travel at the same speed, but they all have different energies in them. So in one end of the piano you will have a short and intense voice of the keys. On the other end you will have a long and gentle voice of the keys. So that's how an electromagnetic spectrum is. And what we are concerned about is the sunlight. So sunlight will have UV light, will have a visible light and will have a infrared lights. And UV is almost 7% of the total light. And there are three types of UV radiations. We divide in UV A, B, C. So UVC never enters our atmosphere, but UVA and B, UVA completely enters our atmosphere, and some of part of the UVB enters our atmosphere. So if any testing that needs to be done, we have to always check upon the what type of UV is entering our atmosphere. So now the light or the photon always have an energy in them. So a shorter wavelength photon on the left side of the graph will have high energy. So just to explain, imagine a glass panel. If I throw this sand at the glass, nothing will happen to the glass. If I throw stones at this glass, probably might break, might scratch, or some part might get damaged. But if I throw this big stone at the glass, it will definitely break. So basically what sunlight does or UV does is they are breaking the chemical bonds. I guess Dr. Prashant told us in his presentation. So these are different chemical bonds. There's carbon-nitrogen bond, there's nitrogen-hydrogen bond, and the second column shows us the energy which is required to break that bond. And since we are a polymer industry, LLDP or polymer is a carbon and hydrogen bond. So to break a carbon and hydrogen bond, you need 393 kilojoules per molecule to break that bond. And so the wavelength of photon with which you can break that bond is 304 nanometers. So 304 falls under the range of UVB to UVA. So anything which is severe than 304 and above will break the chemical bond of polymers. So out of the total light which is there, that is the part which would break the chemical bond. So how the chemical bond breaks? So basically it's called carbonyl formation. So if you see, the shorter wavelength photons will generate high percentage of carbonyl formation compared to the longer one. So carbonyl formation is nothing but, imagine if you are boiling a water. So initially you will see that there are some bubbles, then there are severe bubbles, and then over a period everything will evaporate. So this is happening with the polymer at a micro level. So this is how the chemical bonds break. Then comes heat. Heat elevates temperatures, and because of that high temperatures there are dimensional change in the plastic products. So if anybody here who is into OEM, who are molding OEM parts or something, OEMs always demand this test called coefficient of expansion. So that basically they are in assembly lines. So in assembly lines, during the use of the product, it might expand. So if at all there is a dimensional change in the grade that are using, so they should know, and they would always prefer a polymer grade which has a less coefficient of expansion. And because of heat, yes, evaporation happens, and evaporation is not always of the water. Evaporation happens of different materials also. So the best example is, once you buy a new car, you will get that pungent smell, the nice smell that you are smelling. That is nothing but those are volatile compounds. Those are glues which has been used while fitting the parts, and that's the smell. And over a period of time, that smell will go away because that has been evaporated. And if at all you like that smell, just buy a can of glue, open it and keep it in your car for 2 days. It will again smell the same new car. Then it also does thermal aging and also leads to thermal cycling. So we'll take an example of Singapore. I was fortunate enough, last month I visited ExxonMobil's Singapore plant. They do 19 lakh tons of LLDP at the Singapore plant. So in Singapore there are only 2 seasons. There's either rains or there is a summer. So in the morning and there is a summer, and by afternoon it might start raining. So that temperature drops are from 75 degrees to almost 25 degrees at some locations. So this is called thermal cycling. So why all those parameters are needed is because whenever you are doing a weathering test, the test standard or the test procedures should always consider all these factors, and then the result should be seen. So another example of heat is this is a study by Fisher and Ketola. So here the temperature on the surface of plastic products was measured. So the flakes were fitted on this type of panel. So the temperature of the black is considered as the base temperature, and if you see the temperature of yellow or white is almost down by 10 to 15% compared to the black. So even the colors that you use, the colors that you roto mold also plays a major difference in the temperature of your products. Coming down to the second enemy of weathering is water. This is normally always neglected. Nobody has done any research on how water, and I remember Dr. Prashant said that oxygen is a main enemy of your oxidation. So basically water, what does it do? It do chemical reactions on your products. It facilitates oxygen transport also if it is there on the surface. And the physical effects of water is erosion. Normally we see the paint, the branding on the water tanks get out after a short period of time. It's because of the rainfall, the continuous exposure of the physical impact of rainfall on water tanks. Also thermal shock, as we have seen, water also get absorbed in the surface of the product. So water in types of water is like humidity. Humidity is nothing but the amount of moisture or water in an air relative to its temperature. That's why we call it relative humidity. And we have considered both indoor and outdoors, because any surface is always absorbing water or is evaporating moisture. I mean, basically it's in the process of absorption or evaporation. If there's a moist climate, you can see your fabric gets wet sometime, and if there's a wet fabric, it might, and if a temperature is high, it will soak away. And because of this process also, the product goes under physical stresses, and rainfall is always have a effect on the surface of the product. And then we have dew. Dew is one of the major part of the water which impacts the weathering, because it has the longest dwell time on your products. So dew, for example, in taking the example of Ahmedabad, so in currently also in the evening it's very cold, so, and in the morning it's very hot. So imagine if a product in the evening, if the dew gets generated throughout the night, your product will consume the water, and in the morning when sun comes, the water will get evaporated. And along with water, any low molecular weight material which is there inside your polymer will also get evaporated, and that is how the degradation takes place. So this is how it's been shown that depending on the humidity, what is the amount of humidity, you can see in CO2 evolved over a period of time. So the highest, with highest humidity, you will have the highest CO2 evolved over a period of time. And so for weathering, we have two different test standards or test equipments. So one is ASTM D4329 and another one is D2565. And for rotomolding, I believe 2565 or G115 is what is preferred and what is demanded by major rotomolders. And both the tests are accelerated weathering. So accelerated weathering is fast, repeatable, and you can now equipments are available which you can even establish in-house. So this is how a UV weatherometer of T4329 standard is. So you can put your specimens here, and you have UV lamps on the back, and inside you also have water heaters with vapor and water also is there, and heat also is been the environment is being generated for all the three enemies, and that's how the testing is being done. And for G115, this is how the weatherometer is. It's a xenon arc weatherometer. The lamp is different in this. So this is where the lamp goes, and this is where you mount your specimens. It's a rotating rack and also has a moisture, the water spray inside. The differences are mainly in the lamps that they both can do testings in. So here you have UVA lamp which replicates UVA at 314 nanometers and different other types of lamps. And in xenon arc weatherometer you have the full spectrum light that you can replicate. Also they come with filters which are no aging filters. So you have daylight filter, you have window glass filter, you have an extended UV filter. By using those filters you can judge on what type of product you do. So if you have a product which is inside the glass area or in somewhere it has been installed near a glass area, like majorly is the flower pots, so those can be done with a daylight filter and a window glass filter. Thank you so much.
I request Mr. Kant to felicitate him.